Okay, today we are getting ready to construct an angle bisector. Now, as far as the medium or the level of difficulty on this one, I would say this is between a medium and a difficult one. So we have long surpassed the easy version. So if I'm going to construct an angle bisector, that means I'm not copying anything. I'm not going to have anything down here. I'm simply performing all of my actions on this angle here. So I'm going to call this, I don't know, angle B, because I like B, Mr. Brown. Now, with this, it really does not matter where these rays end. That's sometimes a confusing part for my students because they think that these endpoints actually matter. They also think that point A and point F actually matter. Well, they don't, because if you know what an angle is just two rays that share a common endpoint, and that's the only thing that really matters. So, to construct an angle bisector, you actually need 2 points, and they have to be equidistant. There's a $5 word for you, equidistant from the vertex. So what you do is you take your compass and you're going to construct. Now it doesn't look like A is equidistant and F are both equidistant to B. That just doesn't look right. So you're going to have to construct 2 points that are indeed equidistant from B. So that's why I actually encourage my students to create your own. So I have randomly generated this arc here, and I have randomly generated it that it just has to cross both rays. Now, if you know how to copy an angle, you'll notice that this has started out the same way, but you're not copying anything here. You're just trying to bisect it. The thing that was horribly important was that point right there and that point right there. Those are equidistant to B. So now you can use those 2 points, and all you have to do is you take from this point, and I was taught that you actually pull your compass, you reset your compass from this equidistant point to the other equidistant point. Now, that's how I was taught. Turns out that's a little unnecessary as long as you get somewhere past halfway, past this angle. So I could have actually done that one. I can make this beautiful little rainbow. I can do anywhere down here, anywhere I want to. It's just random. But the trick is, if I do that, then I just pick up from this equidistant point and I go to this equidistant point and I make my mark. And you'll notice my first one lined up with my second one. Or if I go back to where I was and I do that second mark, I was just trying to randomly show you. So from there to there, keep the same setting from this equidistant point. I pick it up and I'm going to put it over here. And then I make my mark there. Or, in the way that I was taught, if I were to go all the way over to my second equidistant point and I were to create that arc, then I do that same setting and I pull it up over here and I make that mark. So what you should notice is this is the original, and then this is where it crossed. Well, because all of these, it doesn't actually matter as long as you go past halfway. These cross and these cross, and if you will notice, they all cross exactly on this ray. And guess what is special about that ray right there? That is correct. It is considered the angle bisector. This part right here is exactly the same measurement as this angle right there. And that is how you construct an angle bisector. Now I'm going to take you through the steps one more time just to make sure, but I'm going to try and do them a little bit randomly. So if this is my angle here, all I'm going to do is first of all take my compass and I'm going to make that great big old mark right there. So I took my compass and I created these 2 points that are equidistant from the original. And then I set my compass up here and I pull that intersection out. I take the same setting and I put it right here, and bam! And this is my favorite because it looks like that you've got a sort of firework out here in the middle, and that makes this angle congruent to that one.